Good morning. One of the key concepts in geographic thought that will get emphasized throughout the course is the notion of location. The great philosopher Immanuel Kant divided fields of study up on the basis of the subject of study, things like biology, studies living matter, geologists study rocks, but two fields take a somewhat different approach to their object of study. One of those is history, which focuses on time as a main theme, and the other is geography, which focuses on place, location, and the relationship of one place to another on the face of the earth. Now, for most of human history, this has not been a critical factor because most people didn't travel very far. They could see to the other end of the valley, or they could locate themselves in terms of 2 days' travel down the river or over the pass into the next valley. But when people started to travel long distances, particularly by sea, then this whole notion of where you are and how to determine where you are became much more critical. We can trace the efforts at trying to do this back at least to the time of the Greeks, probably even further. But in classical times, Greek and Roman times, most sailing, certainly in the Western world, was coastal sailing. People would move along the coastline, often stopping overnight, not sailing at night, rarely getting out of sight of land. So it was really only with the advent of the age of exploration in the 16th, 17th century that it became necessary to develop a more precise way of locating where people were on the Earth's surface. Now, one of the problems, of course, is that the Earth is a sphere, and we're not used to thinking in terms of spherical surfaces. Mostly we think in terms of a flat plane. And of course, when we translate the surface of the Earth onto a map, we are translating something that is curved onto a flat surface, which provides some distortion. But that's another issue. We won't deal with that right now. But how do you locate things on a sphere? Most of us, I'm sure, are familiar with a simple grid where you've got a vertical axis and a horizontal axis and numbers along on each of these, a grid layout, and you can mark something on that grid, look at the numbers on the vertical axis, the horizontal axis, and identify a particular location. But that's on a flat surface. On a sphere, it gets a little tougher. If, for example, I were to give you this ball and point out that it has a red dot on it, and then ask you to tell me, to describe where on the ball that red dot is, you would have a very hard time. Because on this sphere, there's no reference point. There's no place to start from. Now, when we locate things, we almost always start from some known location, frequently where we are. If someone were to come up to me on campus and say, where's the bookstore? I would probably say, well, we're here. If you go down this hallway to the end of the building and turn right and go out the door and turn left and go about 100 yards, you'll come to it. Now, when I'm giving its location, I'm giving them a sequence of information. We're starting from a known spot where we are. I give them a direction. In this case, I say go down the hall, but I could say go east or whatever it happens to be. And some idea of the distance to the location that they want to know. Well, we can do the same thing on the Earth, but we have to have some reference points to start with. Now, as it happens, we do have some built-in reference points when we're looking at the Earth. Now, remember that the Earth is a sphere, and it rotates on its axis. Every 24 hours, it makes a complete spin. That's how we define a day, is the time it takes the Earth to rotate completely around. What that means is that the two poles, the North and South Pole, then, are fixed. Any observer would identify these as the same location. So we have two reference points then, the North and South Pole, for measuring from to locate things on the Earth's surface. Now the problem with the poles, of course, is that they're kind of at the ends and not very convenient, and in areas where there aren't any people. So for convenience, what we've done is to arbitrarily take a point exactly halfway between the poles, draw an imaginary line around the sphere of the Earth, call it the equator, and we measure from there. So we can then indicate where a particular spot on the Earth's surface is in terms of its distance north or south of the equator. And remember that locations on the Earth's surface are measured in degrees, 360 degrees to go around a circle. The distance from the equator to the pole is 90 degrees, and so we can locate any place then as being somewhere between 0 degrees at the equator and 90 degrees north, which would be the North Pole, or 90 degrees south, which would be the South Pole. Los Angeles, for example, is located about 32 degrees north latitude. Now keep that term in mind because we'll be using it a lot. Latitude is one of the very basic locational references for looking at things on the Earth's surface. So that's fine. Because the Earth is a sphere, we can use degrees to identify spots. We can measure locations with reference to the equator in terms of degrees of latitude. But that's only half of the problem, because obviously any point that is, for example, 32 degrees north of the equator could be any place along a line that goes all the way around the world. So that tells us where we are in a north-south direction, but it doesn't tell us where we are east and west. And this gets a little bit trickier because there is no obvious starting point when we look at distances east and west. And for a long time, this caused a good deal of controversy among sailors from various nations. The general practice was to measure their distance east and west from the capital of their country. That meant that British sailors were measuring distance east and west from London. French sailors were measuring east and west from Paris. American sailors measured from Washington, D.C. Russian sailors measured east and west from either Moscow or St. Petersburg, whichever happened to be the capital that month. This must have been particularly confusing because the capital moved back and forth. But it also meant that if you were looking at someone else's maps, you had to make some adjustments because they were measuring from a different location. Now, because British maps were the best that were available in the 17th and 18th century, and probably also because the British fleet was the largest and most dominant factor in sailing in the world during that period, it was eventually decided that we would measure distances east and west from a line running from the North Pole to the South Pole. These lines are called meridians. And we would measure from the meridian that went through the Royal Observatory in Greenwich, England, just outside of London. So that has become our beginning point for measurement east and west around the world. We measure distances in that direction, again in degrees, but in this case degrees of longitude. So we've got latitude telling us where we are in a north and south direction with reference to the equator. We've got degrees of, did I say longitude before? We've got latitude showing us where we are north and south. We have longitude showing us our location east or west of this prime meridian that runs through London. Los Angeles is about 118 degrees west longitude. So those two numbers, the latitude north of the equator, 32 degrees north latitude, and the longitude, 118 degrees west longitude, identifies one place on the Earth's surface in the Los Angeles area. Now, it's important to keep those directions in there because obviously there is also a 32 degrees south latitude and 118 degrees east longitude. So there are 4 places on the Earth that would have coordinates of 32 degrees and 118 degrees. So we have to say it's 32 degrees north, 118 degrees west. Now, that defines a single place, but obviously a degree of latitude or longitude still covers a fairly large area. At the equator, remember, 360 degrees to go around. At the equator, a degree of longitude is about 70 miles. As you approach the pole, it gets less, but we won't worry about that right now. In order to be more precise, we can divide these degrees into smaller units. And so each degree can be divided into 60 minutes. And if you want to be even more precise, you can divide each minute into 60 seconds. Now, these terms have nothing to do with time. The term minute is actually more closely related to the term minute or small. We're simply taking a large unit, a degree, and dividing it up into several much smaller units. And then if we need to be more precise, we can divide each of those a second time, hence the term second. So if we use degrees, minutes, and seconds, we can define an area extremely precisely, any place on the Earth's surface. I one time figured out for this campus, for example, working out down to seconds of latitude and longitude, and I could define an area using those numbers that was roughly the size from the Oviatt Library to the bookstore, north and south, and from Sierra Hall to Science 1 in an east-west direction. Now that's a very precise kind of measure to get using a simple set of numbers. So that's kind of the address system that we use for the planet then. It's kind of like if you were giving someone your address and you want them to come over and study, you say that you live at 8950 Reseda Boulevard. You're giving them 2 bits of information. When you say Reseda Boulevard, you indicate a particular place along a line, and then when you give them the number, you tell them where you are along that line so they can go and find you. It's exactly the same thing with latitude and longitude. Those 2 concepts will identify a particular place on the Earth's surface. Okay, that's it for today. That's all we're going to talk about on latitude and longitude, and we'll see you next time.